Hello and welcome everyone to my channel Code with Ease. Today we are going to discuss about another linked list problem as part of the linked list series, which is intersection point in Y-shaped linked list. So in this we are given two single linked list of size n and m, and we have to get the point of their intersection. So as we can see here, the first linked list has the node values as 3, 6, 9 and then a common, and then the second linked list is having a node as 10 and it is pointing to common. So this common is the node of intersection, and this is what we have to print. This is the output that we need. Where is the starting point of these two linked lists meeting each other? And here we are told that we are given a reference to the head of both the linked list, head 1 and 2 as input parameters, and we have to return the data value of the node where these two linked lists intersect. If they do not, then we have to return -1. The challenge is we have to try to solve this problem without using any extra space. Let's take a look at the expected time complexity, which is order of n plus m, and the auxiliary space as it is told, it is constant. Okay, so now let's try to see how do we solve this question. So let's move to the whiteboard. Okay, so we'll start with a sample Y-shaped list. So we'll have these nodes over here. 1, 2, 3, 4, 5, 6, 7. So this is the intersection point of these two lists. The first list is this 1, 2, 3, 4, 7, and the second list is 5, 6, 4, 7. And this is the intersection point. So our required answer is 4. I also write the expected time complexity over here is order of n plus m, where the n and m are the length of the two lists and the space complexity is constant. So if we have to find this intersection point and we can understand that this is the common node between two lists, we will try to first figure out what is the brute force way of doing this. Okay, so let's understand what should be the thought process behind this. We have to find something that is common and we are giving two different data structures like two lists or whatever. So if something has to be common, we can use loops firstly to traverse and then check what is common and where is it common. So let's say we have an outer for loop. What we will do, we'll start from, let's say, this node, the first node of the bigger list. So we'll make the I pointer of the outer for loop over here, and then we can have another inner for loop because we have to find what is common. Okay, so we can start the inner for loops pointer from this node, and we can check if this node matches this, the outer for loop, wherever it is at. If not, we'll move to the next, then we move to the next, and then we move to this next. So in this way, we traverse the entire second list. None of them matches. Then the I shifts from here to this. Then the same thing we do. Then the I shifts from here to this. Then the same thing we do. Finally, when I will reach here, we will see when we reach from 5, 6 and 4, 4 will be matching. So outer for loop's ith node will match the jth node of the inner for loop. So when that I and j will be meeting each other, when it will be equal, that is when we can conclude that this node is the intersection point, and this I or j, whatever the index is, that is the point of intersection. There can be two questions. Either you will be asked the point of intersection or you'll be asked the node of intersection. It's just the playing of the words. If it's an array question, it could have been a point of intersection. Because if it's a linked list question, it's a node of intersection. So it's just the same thing, but we just have to understand the concept first. So we can use these two loops, traverse the second loop and keep the outer for loop fixed from one node to another, and that is how we can solve this. What is the problem behind this brute force? The problem is, since we have one outer for loop and let's say the length of this list is n and the length of this list is, let's say, m, it will traverse in exponential format because for each node for each node of this, we have to traverse the entire second list. So it becomes n square or n into m. So the brute force complexity will become n into m, which we do not want because our expected time complexity is very clearly given as n plus m. So now we have to arrive at an optimal solution. before we arrive at the optimal solution, there is one interesting pattern that we have to notice while solving this, and that is how we can arrive at the optimal solution. So what is that pattern? If you see the number of nodes in the first list, that is 1 2 3 4 5 5, plus the number of nodes preceding the point of intersection in the second list. That is, if this is the intersection, before that how many nodes are there? 5 and 6, 2 nodes. So this is equal to 7. So this value is actually equal to the number of nodes that we have in the second list, 5 6 4 3. There are 4 nodes, plus the nodes preceding the intersection in the other list, that is 3 nodes before this. So this is also 7. Why we want to understand this pattern? Because let's say I have a pointer p1 over here, and I traverse to the second list. P1 goes here, then 6 4 7, p1 reaches here. Once p1 reaches here, if I move this p1 to the head of the first list and then make the p1 traverse another three steps or 3 nodes forward, so 4 it has traversed and then 3 more, then I will be reaching my point of intersection. Alternatively, if I start from another point of P2, I traverse till the end and then I go 2 steps and then I reach the intersection point. So because of this pattern, we can use the 2 pointers technique to solve it in an optimal way. So we'll see that how do we do that. Okay. So we'll see how does this 2 pointers approach work. So we'll take 2 pointers PTR1 and PTR2 at respective heads of the linked list. Heads of both linked lists. Okay, this is first step. Then make P1 for PTR1 and 2 traverse one node at a time. Okay, one node at a time. We'll see in a dry run how this works. If either of them reaches null, means they have reached the end of the list, reaches null, then plug that pointer, plug that to head of the other list, and finally at some point in time they will meet. When they meet, means P1 is equal to P2 now. P1 is now equal to P2. So you can return either of them. Just return new. That's it. So we'll see in a dry run how this works. So we'll do a dry run now. So let's say I have my P1 over here and I have a P2 over here. Okay. So my P1 moves one step forward and P2 moves one step forward. Again P1 moves one step forward and P2 moves one step forward. Then P1 comes here and P2 goes here. Now next step for P2 would be a null thing. So instead of that, so P2 will move here and P1 will move here. Since it is at null, so now P2 will go to the head of the other list. So P2 will start from here. Okay. Now what P1 will do, P1 because it moved here, P1 will again go to this. It has also reached the null. So now P1 has to go to here. Okay. P2 comes here. Then P1 will reach here. P2 will reach here. Now you see P1 has reached here and P2 has also reached here. Now P1 and P2 are meeting at the intersection point and we have to return P1 or P2, whatever. It's the same thing. So that's the algorithm for solving this. So now let's see how do we code for this. Okay, so we'll do the code changes. So first we'll have the 2 pointers, PTR1 which will point to head 1 and PTR2 which will point to head 2. And we have to have a while condition. So when will this break? When these meet each other. While they do not meet, we'll keep on iterating. We'll keep on traversing. So in this, what we will do, apart from traversing, we have a check over here that if PTR1 is equal to null, let's say it is, then what it should do is it should it should start from the head of the opposite linked list, the other linked list. If it is if it is null, it will do that. Otherwise, it should do the normal traversal. Okay, like we have seen in the dry run also, whenever it was null, it was just going to the other head. So that was the step it was taking, nothing else. Similarly, if ptr2 is equal to null, then also it will move to the other head. Otherwise, it will traverse as usual. So I've used a ternary operator over here to simplify the conditional logic. So this is going to happen till they meet. Once they meet, it's just a matter of returning the node, or we have to return the data. It returns the data value. So you have to return the data value of the node. So you can return either ptr1 dot data or ptr2 dot data. There is one more thing that we have to look into, that if the linked lists do not merge, then we have to return -1. At what case they do not merge? Let's say, okay, it might happen that ptr1 and 2 never met each other. So we will have to consider that also. So we'll first see a happy flow of this first. Okay, so I just forgot to assign it. That's not how this thing is written. Like ptr1 can either hold this value or it can hold, it has to hold something, right? This is just the condition part. So yeah, we'll try to submit. Okay, so it has solved this successfully. So that's about this problem statement. Let me know in the comments below if you have any doubts, questions, or suggestions. And please don't forget to like, share, and do subscribe to my channel if you want to be notified of further videos like this. Thank you so much for watching.